Okay, guys, I am trying something a little different because I recorded the lecture 3 different times yesterday, and all 3 times it was messed up somehow. I don't know. I guess it was the software I was trying to use to do the screencasting. So, anyways, this is what I'm going to do. Just record the video and I'll put it in the PowerPoint and all will be good. All right. So, first of all, we need to review some important terms from the last chapter and previous chapters. So you definitely need to know how to identify the independent variable and the dependent variable in a hypothesis or research question. This is because it is based on those variables which tests you're going to use. All right. So if you do not know, independent variables are usually the variables that predict some sort of change in the dependent variable. So they come before or cause what's happening in the dependent variable. The dependent variable is suspected to be different between groups or to have some sort of effect. The effect is the dependent variable, right? So, then we have to know our levels of measurement. I'm pretty sure most of you guys are good on these, but just to review, nominal variables are categories usually. All of the answers for the question should be categories. Like gender, race, religious affiliation, political affiliation sometimes. Ordinal is categories as well, but those categories make sense in some sort of order, right? So you could either rank categories, maybe based on like how important they are to you, or say, in your top 5 something, or it could be something like political affiliation, but instead of just being Democrat or Republican, it's like liberal, moderate, and conservative, right? So there's 3 categories, but the numbers don't really mean anything. They just make sense in that order, right? Interval variables we've talked about a lot, so I'm guessing you probably know how to recognize those. Those are the scale variables, right? Something from 1 to 10. Those are pretty easy to spot. And then we have the ratio variables, which are real numbers. So 0 has an actual meaning, right? 0 is the lack of it. Also, ratio level variables can be measured with something, right? So they are like height, weight, income, right? Because you can have literally 0 income. Then we have to remember central tendency. We have to remember deviation. If you did not review those lectures, I'm just going to let you go back and review those. I did want to say a little bit about significance level, confidence level, alpha level. They're all basically the same, kind of be used interchangeably, but they are our decision as researchers to decide, like we decide how much we want to be confident in our results or how much error we are willing to accept, right? So if we set a significance level, like we do in social sciences, of 95% or 0.05, then we are saying that we will generally be right 95% of the time. So what we found in our sample is likely true for the population 95% of the time. 5% of the time, maybe the sample says something that the population wouldn't confirm, right? And then we have our one-tailed and two-tailed tests. Remember that one-tailed tests are directional hypotheses or research questions, which just means that it's saying, something is more or less than something else. And then we have two-sided tests, which are non-directional research questions and hypotheses. That's when we don't really know which direction it's going to go in. We don't know if it's going to be more or if it's going to be less. Then we have type 1 and type 2 error. Type 1 is the false positive and type 2 is the false negative. If you don't remember what that means, go back to the previous lecture and you can see the cartoons and the pictures, and hopefully that will help you remember. All right, so we're going to be talking about difference tests. I do want to talk about inferential statistics. This is just review, but I didn't cover degrees of freedom in the last lecture, and that's important because it accounts for the variability in the dependent variable that is due to error. So what I'm saying is, when we sample from a population, we generally have some sort of error, right? It's either in sampling error, right? So how many people like maybe our sample isn't that representative of the population. Maybe it's too small. Maybe it's a little messed up on one variable. We use the degrees of freedom to account for that in all of our statistics. Any kind of statistical formula is going to include degrees of freedom if it's inferential statistics, because from a sample we have to include that error. Effect size is also a very important statistic that we report alongside the significance level, so the p-value. Effect size helps us because it shows us how big the effect is, or the magnitude of the effect. And this is important because just because something is significant, it doesn't mean that it is a big effect, right? It doesn't mean that it happens for everyone. So we use effect size to be able to see whether or not it is a large or small effect. And you can see from this example here that in a sample of 200, sometimes a small effect won't be significant, right? Because the sample is just too small. We didn't find that small effect in this tiny sample, but if we were to sample more people, we might get a significant effect. So, effect size helps us to see that maybe there is an effect, but we didn't necessarily get it in our sample, maybe. This is just a list of all of the difference tests that are covered in Chapter 10. We are going to go over all of these. It's not planned for us to go over all of these in this week. We're going to be doing chi-square this week, and then t-test and ANOVA are next week. So if you want to spread it out and sort of try and remember some of it along the way, that might be better, because trying to cram it all in one day might be kind of hard. So some characteristics of all of the difference tests is that they generally just determine whether there is a difference between the groups and the categories and the levels on some dependent variable. So I use groups, categories, and levels kind of interchangeably. It all means the same thing. For an independent variable that is nominal, we generally have different groups or different categories or different levels within that variable, right? So that's kind of what I explained there. Gender has 2 levels, race has multiple levels, just depending on how many races you include as responses to what is your race question. So chi-square tests. Chi-square tests, all of the different types are used to test differences in the frequency of occurrence of something, right? So the dependent variable is always the number of things in each category, right? Or the frequency of something. So an example research question for a chi-square test might be, are there more male CEOs than female CEOs in Fortune 500 companies? So we're just trying to test, right? Is the number of male CEOs significantly different than the number of female CEOs? So the way that the formula works is it's comparing our observed differences in those two categories to what we would expect if there were no difference between the two categories. So for example, for that research question, if we were to sample 100 Fortune 500 companies, count up all of the CEOs, right, and record whether they're male or female, then we may have, let's say, 60 male CEOs and 40 female CEOs. That is our observed sample, right? For the expected, if we expected there to be no difference, then it would be 50 male CEOs and 50 female CEOs. So that's what we're doing. We're comparing what we observe to what we should expect if there's no difference. We don't generally use chi-square tests to test any kind of research question or hypothesis. People do, put research questions and hypotheses in their papers that are tested using a chi-square test, but really it's just descriptive. It's not that much information that we're able to say, right? Because we can't test any kind of causal relationship. We're not really even testing a relationship between the variables necessarily. We're just telling you, is there a difference between these categories? Yes or no? So I see chi-square tests as kind of descriptive statistics, but it is inferential because we're taking a sample and predicting what we would expect in the population. So there are limitations to the chi-square test. You cannot have any category in the independent variable that has 0 observed count. So that means if we had no female CEOs in our sample of 100 companies, then we couldn't run a chi-square test. But then we wouldn't really need to, right? Because obviously it's different. The other thing is that you can't have any expected category that's going to have less than 5 or 5 or less. So what that means is, say we sampled only 10 Fortune 500 companies. Our expected would be 5 in one group and 5 in the other. That won't work. The sample is too small. All right. Another limitation of the chi-square test is if you have too many independent variables, it starts to get really confusing really fast. Really, you just want to have 2 at the most in your test, because that is still a little, it's interpretable. Otherwise, more than 2, it's uninterpretable. All right, so a chi-square test, a one-way chi-square test, is going to test the difference in the number of things between 2 or more categories. So an example here, I show you, are there significantly more freshmen at AUM than other class standings? And you can see the number of freshmen, sophomore, junior, seniors, their percentages, and then the formula for the chi-squared. And so other chi-square hypotheses and research questions, these are just examples. You can kind of see how one would do a hypothesis and research question, or how you would write one, right? So more people will buy Animal Crossing than Doom. Are there more red Skittles than other colors in a regular sized Skittle bag? So you can see that you can have 2 or more categories in the independent variable, but what we're doing is just counting up the number of things in each of those categories.